Hello, my name is Caitlin or Kate Taylor. I'm recording this on June 27th, 2025. This is my Module 4 application activity, the movement of macromolecules in the flowchart. I hope you can forgive me. I have some notes off to the side just to make sure that I don't forget anything. The first one that I chose, the first macromolecule was aldosterone. This is a steroid hormone that is produced by the adrenal glands and helps to regulate blood pressure and electrolyte balance. This starts in the mitochondria, and cholesterol is transported into the mitochondria and converted into pregnenolone. From there, the pregnenolone goes into the smooth endoplasmic reticulum, or the SER. In the SER, some enzymatic reactions convert pregnenolone into aldosterone. So that's where aldosterone comes from, is the transfer from cholesterol into pregnenolone, and then through some enzyme reactions into aldosterone. The aldosterone then goes back into the mitochondria again. This is for the final steps of aldosterone synthesis and then goes into the cytoplasm. Because aldosterone is lipid soluble, it doesn't use any vesicles. So it goes straight from the mitochondria to the cytoplasm and then into the plasma membrane where it is passively diffused out of the cell. The fate of aldosterone is that it's secreted directly into the blood. It travels bound to carrier proteins and it targets kidney cells. So specifically, it works to regulate sodium and potassium intake, and works a lot in the kidneys. The second macromolecule that I chose was glucagon. Glucagon is a hormone that is produced by the pancreas and is used for regulating blood sugar levels. It starts in the nucleus where DNA is translated into mRNA. From there into the rough endoplasmic reticulum, or the RER. Ribosomes translate mRNA into preprohormone, and from there it directs the protein back into the RER lumen and then becomes just prohormone. So DNA to mRNA to preprohormone and then into prohormone. Then it goes into the Golgi apparatus where prohormone is packaged into matured active hormones. And then it goes into the secret. I really struggle saying that word. I'm so sorry. Secretory vesicles. The vesicles move to plasma membranes via microtubules, and then into exocytosis, where the vesicle fuses with membrane and hormones are secreted. The fate of glucagon is that hormones enter the bloodstream and then they target specific receptors on specific target cells, or they bind to specific receptors on target cells. So more specifically in the pancreas, and making sure that this is developed and put into the bloodstream to help with blood sugar levels. So it's developed in the pancreas, then released into the bloodstream to help from there. The last macromolecule that I did was kinesin. Kinesin has a really short kind of translation in and out of the cell. Kinesin is actually a protein that acts as helps to transfer cellular cargo along microtubules. So it starts in the nucleus. Again, DNA is translated into mRNA, which then goes into ribosomes, and that mRNA is translated into kinesin, and it stays in the cytoplasm, which is the last step, and it's folded into functional proteins from there. Like I said, has a very short pathway. It remains in the cell and it helps to translate cargo. It also kind of helps to assist with cell division and the transportation of vesicles and organelles, which is why it remains in the cell and it helps as like a transporter to help get the resources where it needs to go. So that was my presentation, and thank you so much.